There are four forces that govern everything that happens in the universe. They are the four fundamental forces. Modern physics uses these forces to attempt to explain every observed physical phenomenon. These forces are the gravitational force, the electromagnetic force, the weak force, and the strong force. The gravitational force is the mutual force of attraction between particles of matter. Isaac Newton developed an equation to describe quantitatively the magnitude of the gravitational force. The equation is the mass of the first object multiplied by the mass of the second divided by the distance between them squared, all multiplied by the constant of the universal gravitation. Therefore, the larger the mass of the two objects, the larger the gravitational force, and the larger the distance between them, the lesser the gravitational force. Gravitational force acts between all masses, even everyday objects. However, the masses of these objects are so small, the gravitational force seems insignificant. But when you look at objects of greater mass, such as the Earth and the Moon, the gravitational force becomes more obvious and significant. The electromagnetic force is a force that occurs between electrically charged particles, such as electrons, and is described in electrostatics as being either positive or negative. Objects with opposite charges produce an attractive force between them, while objects with the same charge produce a repulsive force. A useful equation when dealing with the electromagnetic force is the Coulomb's law's equation, where K is Coulomb's constant, Q1 and Q2 are the magnitudes of the charges, and R is the distance between the charges. Therefore, we have that the greater the charge, the greater the force, and the greater the distance between the charged objects, the lesser the force. Next up is the strong force. Now, have you ever wondered how protons stay together in a nucleus? Aren't protons positively charged? Shouldn't they repel? Well, that's where the strong force comes into play. You see, the strong force is the interaction that binds nucleons together in a nucleus. This nuclear force is the attractive force that overcomes the repulsive force between the protons of a nucleus. Some of its properties include that it is almost completely independent of electric charge. For example, for a given separation, the force of attraction between two protons, two neutrons, or a proton and a neutron has the same magnitude. Another property of the strong force is its very short range, only about 10 to the power of minus 15 meters. For longer distances, the strong force is virtually zero. The weak nuclear force, or weak interaction, is one of the four fundamental forces of nature. It is the mechanism of interaction between subatomic particles that is responsible for the radioactive decay of atoms. So it would make sense that the weak interaction serves an essential role in nuclear fission. It is also most commonly seen in beta decay and the associated radioactivity. The predicate weak derives from the fact that the field strength is some 10 to the 9th power times less than that of the strong nuclear force. The term nuclear indicates that it is a short-range force, limited to distances smaller than an atomic nucleus. While compared to all other forces, which hold things together, the weak force plays a greater role in things falling apart or decaying. The weak force, or weak interaction, is stronger than gravity, but it is only effective at very short distances. It acts on the subatomic level and plays a crucial role in powering stars and creating elements. It is also responsible for much of the natural radiation present in the universe. In conclusion, the four fundamental forces govern everything that happens in the universe. All fundamental forces are field forces. The strong and weak nuclear forces have very small ranges, so their effects are not directly observable. The electromagnetic and gravitational forces act over long ranges. Thus, any force you can observe at the macroscopic level is either due to gravitational or electromagnetic forces. The strong nuclear force is the strongest of all four fundamental forces. Gravity is the weakest. Although the force due to gravity holds the planets, stars, and galaxies together, its effect on subatomic particles is negligible.